Chapter 7, Continuous Attention to Technical Excellence. In this chapter, we look at the importance of a continuous attention to technical excellence. And there are 4 antipatterns and patterns. The first one is going faster leads to going slower, the first antipattern. In this antipattern, a focus on velocity, on words like say-do ratio, ultimately lead teams to incurring technical debt and not going back to fix it. And going faster ultimately leads to going slower. If the focus is on feature, and a feature factory, and if teams are just constantly producing new features with no refactoring, with no going back and continuously improving, with no technical debt remediation, no continuous improvement, not only technical debt but also process debt and cultural debt, then ultimately everything will end up going slower. It'll take longer and longer and longer for changes to be made. In the context of software, code will be less maintainable. It will be architecturally harder to make changes, especially if there's a real pressure around time, around velocity, and doing things unsustainably fast. And that's why in Better Value, Sooner, Safer, Happier, it's very intentionally not the word faster. Very deliberately, the word faster is not being used because that can lead to some, as I've just outlined, some very negative side effects. Instead, it's about sooner time to learning, which doesn't necessarily mean faster, where faster is velocity and output. Rather, the focus is on outcomes and quick time to learning. And time should be spent on continuous improvement, on tech debt remediation, on process debt remediation, on cultural remediation, and so on. I mean, in the context of this chapter, which is around technical excellence, it's around making sure that there is refactoring and that technical debt is paid off, or technical delta is paid down, and ultimately this is a business value conversation where it's a business decision. Maybe there's a reason to incur some technical debt or technical delta at the beginning in order to have fast time to market, but ultimately it ends up slowing down progress. Another anti-pattern pattern pair here is agile hollow shell, and in the agile hollow shell, this is a focus on, for example, something such as Scrum without any of the technical excellence practices. So, for example, extreme programming, kind of forgetting some of the extreme programming principles and practices, and teams just doing Scrum with no technical excellence. That again leads to poor code, poorly maintained code. It leads to change being harder and taking longer. So it's very important super important to focus on technical excellence and continuous attention to technical excellence, so that code is maintainable, software is maintainable, it is easier to make change, it is more robust, more resilient, and technical debt is paid off, and that all helps to improve the outcomes. So if as an individual you are working with a team, you're not on a team who's producing software, but maybe you're working with a team producing software as part of a multidisciplinary team, really important here not to fall into the anti-pattern of demanding a never-ending stream of feature. If anything, look for the balance of the different types of work. The good thing here, the pattern here, is to look for a balance between new features, failure demand, improvement work, and the mandatory risk stories that we spoke about in the previous chapter. Another anti-pattern pattern pair here is where the team architecture doesn't match the technical architecture. So Conway's law, an organization is bound to produce systems who replicate the communication structure of the organization. So if, as an organization, there are large monolithic teams, 100 plus people, role-based silos, the organization, it's been found that organizations will likely technically create replicas of that, for example, a monolithic system produced by a monolithic team. If, on the other hand, there are lots of small multidisciplinary teams, then that is more likely to lead to those teams creating componentized architecture with high cohesion, one job and do it well, and low coupling, minimal dependencies between those components, which leads to agility. The reverse is true as well. If the starting point is a legacy monolithic system, it's going to be very hard for a whole bunch of agile teams to be able to work on that monolithic system. So a really important learning for HR here, for org design, for how organizations are organized, is it has to be done in partnership with engineering, with information technology engineering, with software engineering. If there is a reorg, people are organized into small agile teams, but the technical architecture doesn't match that, again, it's going to be incredibly difficult for those small agile teams to actually be able to operate as a small agile team, because there's so many dependencies. You've got monolithic systems. You effectively still have a think big, start big, learn slow way of working until that has been broken up. So the two go hand in hand, and it's very important to evolve both the human architecture and the technical architecture in parallel to get to that point where there are small multidisciplinary teams with a number of components, which gives you agility from a technical perspective. And then finally, another anti-pattern is to focus on tools over people or process. So organizations, for example, using Jenkins, Git, Jira, rolling out these tools with the view that that makes the organization agile. It does not make the organization agile. As I said previously in one of the previous chapters, chapter 4, leadership will make it or break it. This is predominantly around people, and this is around smart people and smart friends with robot friends, and Toyota have a word for this, which is automation. So this is smart machines. So where there are repetitive activities that can be automated, automate them. However, it's not completely devolving any human intervention at all. Robots and machines cannot continuously improve themselves. So automation is machines are smart friends with a clear feedback loop, clear signals coming from the automation to enable human intervention to be able to continuously improve. So that is chapter 7, a continuous attention to technical excellence.